One last problem, then you're done. In this problem, this is kind of an interesting problem. I want to take this trig identity, which we have already proved in a previous lesson, and I'm going to use this trig identity that I've proved to prove this identity. So essentially, I want to take it from this, and I want to make it look like that. Now, here's one big difference. Because I have already proved this trig identity, that means I can move things from one side to the other. Because I know that this trig identity is already equal, I don't have to just work on one side until it matches. I can move things from one side to the other side. So, to get us started off on this, I'm going to do something a little bit tricky, which is to change this theta to theta over 2. So essentially, anywhere there's a theta, I'm going to replace it with theta over 2. Now, the reason I'm doing this is because I know that in the one I need to end up in, I have a tangent of theta over 2. So if I replace all these thetas with theta over 2, that gives me my tangent of theta over 2 that I want. So let's go through and replace all these thetas with theta over 2. Now, on the left, those 2's will cancel, and I just am left with sine of theta. And on the right, there's that tangent of theta over 2 that I want. And I know that 1 plus tangent squared is a Pythagorean identity. That is secant squared of theta over 2. Okay, next, I'm going to move this secant squared up using the reciprocal identity. Like that. So I moved the secant squared up, and it became cosine squared. Anytime you flip them around, they just become the reciprocal identity. And here, I now have a cosine squared, which I know is a power reduction identity. So I'm going to use my power reduction on this cosine squared. There's my power reduction identity. Once again, notice that instead of just theta, I used theta over 2, just like I had before. But the purpose between this one is that those 2's are going to cancel out. Whoa. There we go. There we go. Okay. And I end up with sine of theta equals 2 tangent of theta over 2 times 1 plus cosine of theta all over 2. Now, one other thing that I would notice is that I have some 2's that are going to cancel here. Whoa. Okay, let's try this again. I have a 2 on top and a 2 on bottom that are going to cancel. So that gives me sine of theta equals tangent of theta over 2 times 1 plus cosine of theta. And I notice that I am basically there. Notice that this line is looking pretty darn close to this line. All that I need to do is move the 1 plus cosine over. And I can do that because remember, we're not verifying a trig identity here. We're using a trig identity that we have already proved to prove another trig identity. So when I divide that over, I end up with exactly what I wanted. And there is our last problem of the day. I really like this problem because it kind of uses everything we've done today. Uses our half angle, uses our power reduction. We've got a lot going on in there. But that is it. So you are officially done with lesson 3.2. You can get started on your homework.